Hej och välkomna till stiftelsen Byggekologis Almedalsvecka. Jag heter Nils Söderlund. Jag är med i styrelsen för stiftelsen Byggekologi. Stiftelsen Byggekologi sänder live här från Södra torget 12 här i Visby. Och vi har ett späckat program hela veckan. Vi tjuvstartar lite här på söndagen med 3 programpunkter. Först så har vi Jenna och jag ska ge henne en kort introduktion. Jag träffade Jenna första gången hemma hos mig i ekobyn Understenshöjden strax söder om Stockholm. Där hade vi ett symposium om urinseparering, för vi har urinseparerande toaletter och då hade vi samlat svenska know-how om urinseparering och då var Jenna med där och berättade om sina erfarenheter om att separera urin och göra pulver av det. Men mer om det kommer hon berätta om och Jenna får själv presentera sig bättre än vad jag har gjort. Tack och välkomna.
Tack. Okej. Förlåt, jag pratar lite dåligt svenska så jag kommer prata på engelska så att ni kan förstå mig. But if you do not understand what I'm saying, then please raise your hand and we'll use some translation to help. And also, if you have any questions during the presentation, just in general, I'm always happy to stop talking and answer those questions directly. I'll just share my screen so people on Zoom can see as well. There. Good. Okay, so for the next 30 minutes, I'm going to introduce to you the concept of urine recycling and explain why on a global and local context, it's very important that we start thinking about this and taking action to do it. And then I'm going to introduce the technology that we've been developing at the Swedish University of Agricultural Sciences, or SLU, which we are now having a spin-off company called Sanitation 360, where we are working to commercialize this technology. So first, a little bit about myself. Gotland is now my home, but I grew up in Canada and we had a cabin with no electricity or plumbing, a stuga. And so the toilet was just a hole in the ground, a nutdas. And I remember from a very young age, as young as 6, questioning my parents on the drive home back to the city. Why did we use drinking water for our flush toilets? And then when I was in my late teens, I got this book on composting toilets. And during this read, I learned that we can actually use our excreta, our pee and poo, as a fertilizer. And so it further boggled my mind as to why do we have this flush wastewater system that is completely wasting our natural resources. So this led me to study bioresource engineering, and ultimately I ended up in Sweden to do a PhD because I wanted to reinvent the toilet. And so it's an honor here today to be presenting to you what we've been doing. And during my studies, I also learned that having access to a wastewater treatment plant is also a luxury. So we have actually a global crisis where only 20% of our municipal wastewater goes through any type of wastewater treatment plant. And you may think this is a global south problem. No. In Canada, where I'm from, there's a city, Victoria, on the west coast. It built its first wastewater treatment plant in 2020. Till then, they had a pipe going out into the ocean because the solution to pollution is dilution. There's other parts in Canada that still have no access to a wastewater treatment plant. A waste truck that has a vacuum on it comes to the house, collects it, then transports it outside the community and dumps it into the environment. It gets worse than that. Only 7% of the global municipal wastewater goes through a wastewater treatment plant that effectively removes the pollutants such as nitrogen and phosphorus. So what does that mean? Well, each time we go to the bathroom, we're contributing to eutrophication. It's calculated that the Baltic Sea, 97% is suffering from eutrophication. And what it is it's too much nutrients in the water. Then the algae eat this They form these big algae blooms. Then as they die, it starts to sink to the bottom. And during that decomposition process, it consumes oxygen and we get these dead zones. This figure is showing the dead zones around Gotland. The gray area is showing where there's 2 milliliters of dissolved oxygen per liter of water. The black zones are showing where there's 0 milliliters of dissolved oxygen per liter. Life cannot live there, and this area is growing. And now, we often blame agriculture. And yes, agriculture does play a role. So this figure here is showing the anthropogenic release of nitrogen into the environment from Sweden. And you can see the first bar, agriculture accounts for just over 40%. But what we don't acknowledge is what going to the bathroom is doing. We account for almost 30%. So you may wonder, how is it that our wastewater has so much nitrogen in it? It starts from the field, where we apply fertilizer, the nitrogen, phosphorus, potassium. The plants grow, they take up these compounds. We harvest the plants, we eat the plants. And then as adults, we do not accumulate these compounds. Instead, we have a net balance. So quite literally, we are what we eat, and what we eat is what we excrete. So it means that in our excreta are the exact same compounds that were used to grow the food. So this is our global crisis number 1. Second global crisis that we're facing right now is the cost of fertilizer and the cost of food. And it's in the media now, so I assume you've seen it, but it's a crisis that was starting even before the invasion of Ukraine. Access to fertilizer is vital in order to have good yields. So what does it look like if we do not have enough yields? This is from my plot trial in just outside of Roma last year. Mineral fertilizer, you see it's nice and lush and green. No fertilizer in the middle. It's shorter, it's yellow, compared to then the urine fertilizer that looks quite great. The one without the fertilizer had a 35% smaller yield. So this crisis that we're in right now with the cost of fertilizer, we're going to have issues with the years to come because of the decrease in yields. Hence our work at SLU, where we're looking at how to recycle the nutrients in urine in order to be able to better manage these natural resources while also decreasing our impact on the environment. So why urine? Urine contains 80% of the plant nutrients that are found in wastewater. And compared to feces, it contains majority of the nutrients, whereas feces has a lot of carbon. And carbon is essential for the soil structure and maintaining the soil structure. But if we want to focus on producing a commercial or a viable fertilizer, we're focusing on urine. The second reason is that urine constitutes just 1% of the volume of wastewater. So we generate about 1.5 liters per person per day of urine compared to over 150 liters of wastewater per person per day. So the next question you might be thinking of is, if urine is so great, why aren't we using it now? In Sweden, if we go back 100, 150 years, we were using excreta as a fertilizer. And 3 things happened globally. 1, we discovered bacteria. Before, we thought we got sick from breathing in the air, and then we had microscopes and realized that there's bacteria and that in our feces there's a lot. So we realized we needed to have a barrier between us and the feces. And then as cities were expanding, especially Stockholm, the rate at which they were trying to export the excreta from the city to the fields, it became difficult. So they introduced water closets so that we could flush our excreta right into the surface waters without having to handle it. And so we had that barrier and also a way of getting it out of the city. And then the third thing that happened was the Haber-Bosch process. And that's where we had the invention that can extract nitrogen out of the atmosphere and produce a concentrated fertilizer. And so urine or human excreta and animal manure became less important and also less attractive. This synthetic fertilizer extracted out of the atmosphere is also a lot nicer to deal with if you think of smell. So we have challenges ahead of us, as we don't want to revert back to defecating and peeing in a bucket and having to transport it out to our field, right? We need innovation that makes it accessible for everyone to do it and that they don't have to have it as hands-on, like in that composting book that I showed at the beginning. So what we're working with is large volumes. Each one of us is producing 1.5 liters per day, as I said. So if you think of Visby, that's maybe 40,000 liters a day. Think of Stockholm, 1 million liters of urine per day. And we only apply fertilizer once or twice per growing season. And in Sweden, we have 1 or 2 growing seasons. So what do you do with those millions of liters of urine accumulating? The second challenge is the concentration. When we go to the bathroom, we have 95% water in our urine. So it means all the compounds that are in it, it's not very strong concentration compared to the ammonium nitrate that we're producing synthetically out of the atmosphere. To give a little bit of context, if I want to fertilize my barley field with 90 kilograms of nitrogen fertilizer, I would need 15,000 kilograms of urine per hectare. Compared to mineral fertilizer, I would just need less than 500 kilograms. So you can see the magnitudes of differences in terms of logistics, like storage and transportation and application. So hence, our solution that we've been developing is to prevent urine from going into the wastewater so that we can stabilize it chemically and then convert it into dry urine or dried fertilizer that can be used with conventional farming equipment. So this is the product from last year's collection that now is being used to fertilize this year's barley crop. And I can pass it around. You're welcome to look at it. You're welcome to open it. You can smell it if you want. It's up to you. It doesn't smell so strong. And so that's the fun part about our technology is that we chemically stabilize the urine so that it doesn't start to decompose in the same way. I'm sure many of you know that smell of old urine is rather disgusting. But with this technology, we're able to prevent that from happening and then dry it out and produce this solid product. So it's based on the work at SLU. And the goal is that we want to enable a circular economy to be built within the sanitation sector and also help to build more resilient communities. Because right now we are dependent on foreign sources of fertilizer. And with this, we can decrease that dependency. Now I'm going to give you a quick chemical intro or chemistry introduction to urine. Bear with me. So the compound there is urea, and that's the most commonly used nitrogen fertilizer in the world, and it's the main form of nitrogen when we go to the bathroom. However, it quickly changes to ammonia, and that's the smelly stuff, and it's volatile. So if we just leave it, we lose the nitrogen. So that's why we can't just dry nitrogen as it is. And the reason why this happens is these urease enzymes. And they are found everywhere. They're in the soil, they're on our hands, they're ubiquitous. And bacteria use them to convert the urea to ammonia to utilize the energy. And this is what we want to try to block so that we can keep the nitrogen in the form of urea. And then we can dry the urine. We can take away the water quite easily. And we do this with pH. So we increase the pH, this blocks the enzyme, and then we can dry it. So then what comes out is a powdered form, and then we're working on pelletizing it. So what's going around now is our first trial of trying to pelletize it. Both forms have been used with conventional farming equipment, which was my most exciting time in terms of this research, that we actually had a urine-based fertilizer used with a seed drill that was putting in barley and our fertilizer into the ground at the same time. It was very exciting for us. And you can see that the concentration, so liquid urine when you go to the bathroom, less than 0.6% nitrogen. And then what's coming out from our system is over 8% nitrogen. And in the lab, we're reaching 20% nitrogen. So we're hoping that we can scale that up into the field as well. In terms of hygiene, so bacteria, viruses, and other types of pathogens, I did an extensive study during my PhD to assess what happens to them during the drying process. And we meet the US EPA and WHO guidelines for reuse through the inactivation of these organisms during the drying and storage process. We also meet the guidelines for heavy metals. Because it's so strict as to what we're allowed to put on our fields, because the EU has regulations, so does Sweden, as to what can go onto our fields. The food we eat is quite clean, which means the urine is also very clean. And then I get a lot of questions about pharmaceuticals, so I'll spend a little bit of time on that. In short, pharmaceuticals with urine as a fertilizer is a very low risk. Sweden did an extensive study looking at what happens with the conventional wastewater treatment plant, where the systems are not designed to extract pharmaceuticals. And so at the moment, we see that most of them pass through, and we've had devastating effects on our fish, on our frogs, and also on birds' eggs by releasing these pharmaceuticals into the environment. And also basically every river in Europe and most parts of the world, there's already pharmaceuticals in those surface waters, and we're already consuming these pharmaceuticals. Compared to putting it on the land, and this was using not just urine, but black water, so that's urine, feces, toilet paper, and flush water as a fertilizer, one would have to consume carrots or potatoes for at least 5,000 years every single day to get one dose of the pharmaceuticals. And that was for the most resilient of the pharmaceuticals. The others was 15 to 20,000 years. So the conclusion was that it was a 10 times higher risk to have our pharmaceuticals going to wastewater treatment plant compared to using it as a fertilizer. Saying that, we see that it's a low risk for humans, but just as we see that having it go out into the water, we see the impact that we have on the aquatic ecosystem. We don't want to make that mistake again with the terrestrial ecosystem. So we have a PhD student at SLU who's looking at how to effectively remove the pharmaceuticals during our drying process so that we can have a clean fertilizer. And it should also be noted that every time we apply fertilizer onto the field, we're changing the bacteria culture there anyways. And so by adding the pharmaceuticals, what will be happening to that as well? So that's the concern that we have. So now into the more exciting stuff is our current installations. So this toilet here is at VEA Sud's head office in Malmo. You're welcome to go see it. We have another installation in Uppsala at SLU, and it's a urine diverting seat. And this is part of a Rewise EU funded project with 2 more installations to come. The second project is based on Gotland, where we have 2 funders from JTI and the EU, where we have a full cycle implementation project. So we're partnered with the local toilet rental company, Touchdown. We collect urine from them, we process it into the fertilizer that was passed around, we grow barley, and then we're connected with a local food producer who is then evaluating the quality of the grain to see if that is something that they can use. We're in our 2nd year now. The food producer or drink producer is very happy with the quality, and so now we're looking at how to certify the product so that they can use this and sell it as well. And so this project with the N2 Brew, which is funded by JTI, goes until 2023. And then our newly funded Peta Green project starts in 2023 and goes until 2026. So has anyone used a urine diverting toilet before? I know, yeah. Okay, nice. That's always the nice thing about being in Sweden is that it's not that foreign of a concept. In Canada, no one's ever seen one. So I have a new model here that I'll introduce as well. But basically, the old toilets had a hole here. And often, especially in public toilets, if you sit on it wrong, you get the feces and the toilet paper stuck in here, and the flush doesn't necessarily get it out. So for public toilets, urine diverting toilets were not so nice. So this new design uses surface tension instead to separate the urine. So you sit down, and then the feces and flush water and toilet paper goes here, and then the urine follows the curvature of the system to collect the urine. And this is a dry unit that will be implemented on Gotland in partnership with Touchdown. So we will have this up and running soon as well to convert these into urine diverting toilets. We also collect with urinals. So the gray one is a male urinal. 4 people can go at the same time. The pink one will be arriving on Gotland soon. It's a Danish and French design. It's a female urinal. So one steps up, pulls down the pants or hikes up the skirt, and then squats, and the urine is collected through there. They've had great success at festivals and at running events, and I'm excited to see how it is perceived here. Obviously there's no wall, so we have to see how people perceive this as well. So as much as we have technology to help address this, we also need to think of the social side and how acceptable it is with that as well. And with touchdown, even with the male urinals, we put little fences around anyways to put a little bit of protection. So then in terms of our company, Sanitation 360, we're looking to commercialize this concept. And this is our plug and go unit that we built with funding from Bill and Melinda Gates Foundation that's designed to fit to one toilet. And so it processes 6 to 10 liters a day. And then we have our Gotland system that's currently being built into a trailer so that I can drive around, pump out the urine from the urinals, and then process it as I go in town. And so it uses solar energy, and then we can have the concentration happening there so that we don't have to transport it as far, which makes the logistics and the storage easier. So overall, what we're trying to do is use Gotland as our template to see how we can get this full cycle implementation project going. And so far we see that there is strong interest between Touchdown and the drink producer, and we have other interest from other food producers as well. And so in the coming years, it will be great to see how we can expand this also to the mainland and beyond. In terms of the development goals, obviously we fit into number 6, which is providing clean water and sanitation. But what is quite interesting is with this introduction of better sanitation, we hit on a lot of other goals because we're working to protect the life below water. We're working to decrease the greenhouse gas emissions. Producing the synthetic fertilizer from the atmosphere releases a lot of what we call reactive nitrogen back into the atmosphere. At the wastewater treatment plants, when they're trying to remove the nitrogen, reactive nitrogen is also released into the atmosphere. So we're helping to deal with that. Also sustainable communities, making toilets easier to manage so that both girls and boys at schools can have access to better sanitation and thus stay in school, and obviously fertilizer and zero hunger. So what does that mean on a global context if we were to all of a sudden recycle all of our urine? In Sweden, we could replace 20% or 25%. And we can't replace 100% in Sweden because when we apply the fertilizer, we have losses there directly, emissions to the air and also to the ground. Then we harvest, we have losses there. We have food processing, losses there. We have losses at the grocery stores, in the restaurants, in our own house. By the time we consume it, there's only 15 to 25% left of those nutrients. So we need to make improvements along the whole line. And there's another talk by SLU on Wednesday that I can recommend, and it's talking about food waste and how we can address that. And we need to have the efficiencies increase in all of those steps. But if we look in other places where you see the darker colors, they're struggling to access the fertilizer, whether it's the cost, whether it's because of the infrastructure that it's not accessible. So here, there's great potential based on the population density there, the amount of fertilizer that could actually be replaced. So globally, we have 2 crises happening, and action is definitely needed now. And Sanitation 360, along with our partners, is working at this unique approach to enable the circular economy to be built within our sanitation sector. We're working on changing the world, and we hope that you're interested in joining with us. Thank you.
Finns det frågor bland publiken om Jennas? Ja. Maurits, du får komma med, och ta dig micken.
I didn't understand how you dry it, the urine.
Yeah,
and
Thanks. So for drying it, it's quite simple. We have fan and heat. So in the lab, we just use conventional fans that we buy at Biltema, and then we add heated air. And now we're working with another organization that builds solar heat storage tanks so that we can heat and dry the urine just with solar panels. But it's just a fan to drive evaporation and then heating up. So the science or the engineering that happened was with the chemistry to figure out how to block that urease enzyme and prevent the nitrogen from changing form. That's what we've been evolving. It does take energy, for sure. Right now, for the systems that we did not optimize, operating energy was 400 watts, and that was so operating continuously. And now we're looking at this solar panel driven system with the heat energy storage tank. So we heat up oil using solar energy, and then we can transfer that heat to the urine to heat it up so that we don't have to use electricity or directly to the grid. So that is another question for the So that's why we're also focusing with the public toilets and focusing on the peak nitrogen or the peak urine problem that we have in the summertime with all the tourists. And there we have enough energy to use it.
Har vi några fler frågor i publiken? Ja.
Thank you, Jenna. Some part of the process you raised the pH to above 10, and how, maybe you mentioned it, but how is that done? I know that you can use ashes from, so maybe that's another circular problem that is solved.
Thank you. So we initially did use wood ash, which we have a lot of in Sweden, and that worked very well to raise the pH. However, we got pushback from the agricultural sector where they did not want wood ash coming into the food sector because of the worry with heavy metals. So then we moved over to calcium hydroxide, which is also a byproduct that we produce here on Gotland, but there's also risk of heavy metals, and it didn't work as well as wood ash. So now we've come up with a new recipe, but we're keeping it as a trade secret at the moment. But what we're doing is we're looking at finding waste products that have the right pH that we need so that we can keep within this circular concept.
Okej. Fler frågor? Här har vi en.
Are you looking at other sources of urine like pigs or livestock?
Great question. So we need a clean source, because if it mixes with the feces, then the form of nitrogen will change directly. It's an instantaneous reaction. However, there's a Dutch company that has designed basically urinals for dairy cows, and the dairy cows get trained to back up and engage with a system that then comes out, and then they go pee and the urine is collected cleanly. So for dairy cows, we could apply the technology. For others, not yet. We had a big interest in Kenya. They have rabbits, and they collect the rabbit urine to then use as a fertilizer. But for the same problems that we have with the volumes that you're generating, they wanted to apply our technology, but it's very hard to collect it separately. So we checked the pH and the nitrogen concentrations, and it was already in a form that would be lost to the atmosphere.
Yes, I wonder how would this technology scale to like city scale or larger places in terms of logistics and handling and also business models?
Great question. And this is why we're starting with the portable public toilets, because it's already being transported, it's already being sourced in that way. So it's an easy entrance into the market. The next will be bigger buildings, office buildings, schools, where we can have multiple toilets being connected to a system in a basement. And then there is going to be some service provider that does have to come and collect the end product and take it away and replenish with the fresh stabilizing media. In terms of scaling up that quickly, it's going to take time. People are very satisfied with our current wastewater management system, but we're seeing that change is needed. And so there are projects like this EU funding that is supporting this. And so together with that, we hope that we can find a sustainable way of scaling up.
The single seat toilet, like the one in at Via Syd in Malmö, that's not a sustainable business to have. Yeah, a single system and a single toilet.
Yeah. So when we started, we thought that it could work, but then we're academics, we're engineers, and then when we got into the business world and got all these questions, we realized that that wasn't a good enough approach because of the amount of labor that would have to go into each system, and also that initially we thought maybe individuals could also handle it, but we want a system that 99.9% of the world is going to accept using it, and only less than 1% is going to accept taking out their own urine and handling it. So for the summer stugas in Sweden, we see that maybe the single toilet solution could work, but not for the mass scale. So we're not focusing on commercializing that system anymore. We're focusing on the large scale system.
Okej, jag har en till fråga här.
In Stockholm archipelago, there are two processes going on right now in the Nämnde archipelago. We are going to be a national park, and as well we are in the process of being UNESCO biosphere area as well. So UNESCO is looking carefully about our projects.
Köpa istället för de här kommersiella syntetiska fertilizerna. Och kommer de att konkurrera så att säga med det som finns idag?
So to make sure I understand, when is the fertilizer ready?
Om det är möjligt och när det kan finnas en säck att köpa för bönderna och kommer det vara kommersiellt möjligt? Dina visioner.
Yeah. So with the EU-funded project with the Peter Green, that's what we're working on. And so we're looking at collecting over 150,000 liters of urine to then process into fertilizer. But then we will focus on our drink producers' needs first and then expand from there. And the limitation that we have found for commercialization is that we need certification. And right now in Sweden, there is no proper certification that meets these recycled products. So we just applied also for Formas for 4 million kronor that we hope they'll give it to us in collaboration with RISE and Ecoloop and SLU and my company to see if we can develop a certification process that would enable it to be sold more easily. So it's going to be sold hopefully in the coming years, but I don't have an exact year. And yeah.
Jag fick en fråga också från publiken hur mycket urin det här motsvarar.
So 1 liter gets concentrated to roughly this amount.
En liter blir, då förstår man ju hur mycket det finns när man går och kissar. Jag hade sagt mycket mer. Okej, då får jag tacka så mycket för Jenna och intressant. Och det känns som ett verkligen viktigt ämne det här för att gå framåt. Tack.